following function gives the value of an investment account in dollars that pays 6% interest compounded annually, where t is the time in years. So we're given the exponential function f of t equals 1,000 times 1.06 raised to the power of t. So the first thing to recognize here is the exponential function f of t is in the form f of x equals a times b to the x, where the base b is equal to 1 plus r, where in this case r would be the interest rate compounded annually. So the given function is in the form a times b raised to the power of t because we have a function of t where the base b is equal to the quantity 1 plus r. So notice in this form, we can easily recognize that r is equal to 0.6 or 6%, which is the amount of interest earned compounded annually. Now for part A, we're asked to determine the equivalent continuous interest rate. In order to determine the continuous interest rate, we need to recognize that when we have an exponential function in the form f of x equals a times e raised to the power of kx, the value of k would give us the continuous interest rate. So in order to determine the value of k, we need to recognize that if we wanted these two exponential functions to be equivalent, then b raised to the power of x must be equal to e raised to the power of kx, and therefore it follows that the base b must equal e raised to the power of k. So looking at the given exponential function, again, notice how the base b is equal to 1.06, and therefore if b must equal e raised to the power of k, we would have the exponential equation 1.06 equals e to the k. So if we solve this exponential equation for k, we can determine the equivalent continuous interest rate. So to solve this exponential equation, we'll use the definition of a logarithm, where if we have the exponential equation y equals e raised to the power of x, this is equivalent to the log equation x equals natural log y. Remember, natural log is log base e. So as a log equation, we would have, of course, natural log because we have log base e. A logarithm is an exponent. Notice how the exponent is k, so the natural log equals k. And because we have e to the k equals 1.06, our log equation is k equals natural log 1.06. So now we can go to the calculator to get a decimal approximation for k, which again will give us the continuous interest rate as a decimal. So we enter natural log 1.06, close parenthesis, enter. And let's go ahead and round to 4 decimal places, which would be approximately 0.0583, which as a percentage would be 5.83%. So the equivalent continuous interest rate is approximately 5.83%, which means an account that pays 5.83% continuous interest annually would give the same return as an account that pays 6% interest compounded annually. Now for part B, we're asked to write the given exponential function in the form f of t equals a times e raised to the power of kt, and we already have all the information we need in order to write the exponential function in this form. We would have f of t equals a, the initial or starting amount is still 1,000 or $1,000, and then we'd have times e raised to the power of kt, and we already know k is approximately 0.0583, so the exponent on e is approximately 0.0583 t. And now let's go ahead and use the graphing calculator to verify these two exponential functions would be equivalent, or almost equivalent, because we did round this value of k, and therefore there will be a slight difference in the function values. So let's go to the graphing calculator, and we're going to press y equals, and notice how I've already entered the given function in y1, though I use the variable x instead of t, and I've also entered the exponential function with base e in y2. And now we'll use a table feature to compare the function values or y values for the same inputs or x values. Before we do this though, let's make sure the table set is on automatic. So we'll press second window, and notice how automatic is highlighted under independent. If it wasn't, I would go down to highlight automatic, and then press enter. And now we'll go to the table of values. So we'll press second graph for the table. And let's scroll back up to x equals 0. And now comparing the y values, meaning y1 and y2, notice how the values are almost the same. Again, they're not quite the same because we did round the value of k with the exponential function with base e. But comparing these y values, it is enough information to verify these two exponential functions are equivalent. I hope you found this helpful.